Hello everyone, my name is Kenneth Miller. In this presentation, I will summarize my applied data mining project on neighborhood decline and infrastructure in Kansas City. I'll combine dangerous buildings, demolished buildings, and pothole complaints to investigate whether areas with housing decline are also experiencing neglected street infrastructure. I'll briefly cover the data sets, how I cleaned and merged them, the analytical methods, the results, and what they mean for equitable city services. The guiding question for this project was straightforward. Are areas of housing decline also reporting more potholes? This matters for equity and safety because residents living amid dangerous buildings may also face deteriorating roads. Finding where these conditions overlap can help prioritize investments for the city for the future. I used 4 public data sets from the Kansas City Open Data Portal. The Dangerous Buildings and Demolished Dangerous Buildings datasets provide structural indicators of neighborhood decline. The Pothole Tracker contains 311 complaints that reflect functional street conditions. Parcel data was used to fill missing zip codes for dangerous buildings. Together, these sources created a comprehensive view across the city. The data preparation focused on comparability across sources. We standardized zip codes, then matched dangerous buildings to parcel addresses to fill missing zip codes. About 88% matched on strict rules, with the rest excluded to avoid false positives. We then aggregated counts by zip code and merged them into one tidy table, with each variable as a column and each zip as a row. We used descriptive statistics to find hotspots. A simple linear regression did not show a global link between demolitions and potholes. However, descriptive comparison showed some zip codes with both high housing decline and high potholes. Next phases will incorporate spatial clustering and additional predictors to capture localized effects. Table 1 from our project lists the 15 zip codes with the highest combined burden of dangerous and demolished buildings alongside pothole counts. East side zip codes such as 64127, 64130, and 64128 show high values across the board, while downtown areas like 64108 have very high pothole counts but fewer building issues. Figure 1 from our project was a stacked bar chart that shows the total burden per zip and the composition of that burden. The base of each bar is the count of dangerous buildings, followed by demolitions, then potholes. The pattern indicates that some neighborhoods face compounded decline in both housing and roads, notably 64127 and 64130, while others such as 64108 have primarily infrastructure problems. For our conclusions, the neighborhood decline in infrastructure neglect overlap in specific zip codes, particularly on the east side. Other areas experience infrastructure issues without the same level of building decline. Limitations include incomplete zip code enrichment, with roughly 12% being unmatched and having no zip codes, as well as the coarseness of zip level aggregation and a simple one predictor regression. These factors motivate more granular geographies and multivariate models in future work. The next steps for this project would be to include moving to neighborhood or council district boundaries, adding explanatory variables such as traffic volume and demographics, and incorporating multiple years of 311 data. If the dataset scales significantly, distributed computing like Apache Spark will enable efficient joins and modeling. And then here is a list of our references. And thank you guys for watching my presentation. Any feedback is well appreciated, and I thank you guys and good luck in the future.